All right, exam season is officially here, and we're about to do a super fast, super effective revision of a huge chapter in chemistry, chemical reactions and equations. And how are we going to do it? By using a secret weapon, an exclusive set of a topper's notes, designed to nail those guaranteed marks. Oh yeah, these are not your average notes. This is the secret sauce, the good stuff, distilled by someone who absolutely aced their exams. The whole point of these is to focus on the concepts that you know are going to show up. So get ready to take some notes yourself, and let's do this. Okay, so first things first, before we can even get into all the cool equations and different types of reactions, we have to ask the most basic question of all. What even is a chemical reaction? You know, it's actually pretty simple when you break it down. A chemical reaction is just a process where the old bonds and the stuff you start with, we call those reactants, they break apart, and then new bonds form. And this creates totally new substances with completely different properties. We call those the products. So really, old stuff breaks and new stuff gets weighed. That's it. So how do you know if you're actually seeing one? Well, you've got to look for the signs. And trust me, this slide right here, this is a guaranteed 1-mark question. So look for these 5 clues. Is there a change in state, like a solid suddenly becoming a gas? Did the color change? Did the test tube get weirdly hot or cold? Are you seeing bubbles form? Or did a solid just appear out of nowhere in a liquid? If you see any of these, ding, 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 you've got a chemical reaction. So now that we can spot a reaction, we need to learn how to, write it down. We need to learn to speak the language of chemistry, and that means writing and balancing equations. And there are basically 2 ways to do it. On the left, you've got the word equation. It's simple, sure, but it's also kind of long and clunky. But on the right, that's where the magic happens, the formula equation. It's short, it's packed with information, and it's what scientists and chemists actually use. It's the pro version. But hang on. If you look really closely at that last equation, Mg plus O2 changed to MgO, something's not quite right. See it? We have 2 oxygen atoms on the left, but only 1 on the right. So that brings up a really, really important question. Why do we even have to balance these things? And here is the answer. It is the law. Seriously, it's the law of conservation of mass, which is a fundamental rule of how our universe works. You can't just create or destroy atoms whenever you feel like it. So the bottom line is, the number of atoms of each element on the left side of the arrow has to be exactly the same as the number of atoms on the right side. No exceptions. So how do we do it? We use what's called the hit and trial method. Let's walk through this one together. Okay, first step, look for the most complicated thing, which is that Fe3O4. It has 4 oxygens, so we need 4 oxygens on the left. Easy, let's put a big 4 in front of the H2O. Boom, oxygen is balanced. But wait, now that gives us 4 times 2, 8 hydrogens on the left. So we hop over to the right side and put a 4 in front of the H2 to make 8 hydrogens there. Perfect, hydrogen is balanced. Last step, the iron. We've got 3 on the right, so we just need to put a 3 in front of the Fe on the left. And we're done. It's perfectly balanced. See? It's not magic. It's just a little logic puzzle. Okay, deep breath. Now we're at the main event. This is the stuff that makes up the bulk of your exam questions. You absolutely have to know the 5 main types of reactions. If you know these, you are golden. Let's get into them. First up, we have the combination reaction. And honestly, the name pretty much says it all. This is when 2 or more simple things, let's just call them A and B, get together and combine to form one single more complicated thing, AB. Simple as that. And here's a perfect real-world example. Whitewashing. When quicklime is mixed with water, they combine to form slaked lime. Now, if you've ever seen this happen, you know that bucket gets really hot. That's because it's an exothermic reaction, which is just a fancy way of saying it releases a bunch of heat. Next up, we have the total opposite of combination, the decomposition reaction. This time, we start with one big compound, RAB, and it breaks down into 2 or more simpler little pieces, A and B. You can kind of think of it as a chemical breakup. But here's the catch. Unlike things coming together, breaking them apart takes energy. You have to put energy in to make it happen. And that energy can come in three main forms: heat, light, or electricity. Super important detail to remember. All right, reaction type number 3, displacement. This one is all about competition. It's like a chemical popularity contest. You have a more reactive, stronger element that comes along and just kicks a weaker, less reactive element right out of its compound. And the classic example you have to know is this: dropping an iron nail into a blue copper sulfate solution. Iron is more reactive, so it boots the copper out. Now, the thing you have to remember for the exam, the key observation, is the color change. That bright blue solution starts to fade and turns a kind of light green. That's your big clue. So what happens if you have two compounds? Well, that's our fourth type, the double displacement reaction. This time, it's not just one element getting kicked out. Instead, the two compounds basically just swap partners. They exchange their ions to form two completely new compounds. I love how the notes put it here. Just think of it as a partner swap. It's the perfect way to remember what's happening. And a really common result of this partner swapping is that you form a solid that won't dissolve in the water. We call that solid a precipitate. And last but not least, number 5, oxidation and reduction, or for short, we just call it redox. Now, this one sounds complicated, but the basic definition is simple. Oxidation is the gain of oxygen. Reduction is the loss of oxygen. And the single most important thing to remember is that they're a team. They always happen together. You can't have one without the other. So you might be thinking, okay, that's 5 things to memorize for my exam. Great. But where does this stuff actually show up in the real world? Well, let's take a look at where you see oxidation happening every single day. Seriously, it's everywhere. You see that reddish-brown, flaky stuff on an old gate or your bike chain? Yep, that's rust. That's a type of corrosion, which is just the oxidation of iron. Or have you ever opened a really old bag of chips and they smell just awful? That's called rancidity. It's what happens when the fats and oils in the food have oxidized. So yeah, this chemistry is happening all around us, all the time. Okay, we have covered all the theory from these amazing notes. Now it's time to put that knowledge to work. Let's solve a real question from a past exam and see how everything we just learned translates directly into marks. Let's tackle this. The question says, a solution of substance X is used for whitewashing. Wait a minute, we just talked about this. So part 1, name X and write its formula. We know from our notes that's calcium oxide, also called quicklime. The formula is CaO. Part 2, write the reaction of X with water. Again, we literally just saw this. It's our combination reaction example. CaO plus H2O gives us CaOH2 plus heat. And that's it. Full marks. A perfect answer, taken straight from the notes we just covered. So, as we wrap up this whirlwind revision, here are the final tips straight from the Topper's Playbook. 1. Go over all the definitions again. 2. Practice balancing at least 5 different equations until it feels easy. 3. Memorize the colors. They are huge clues in exam questions. And 4. Know all 5 reaction types and have one solid example for each one ready to go. You do that, and I promise you are going to rock this exam. And just like that, we've gone from the very basics of what a chemical reaction even is, all the way to solving an actual exam question. You've just mastered the fundamentals. So the only question left is, with this knowledge, what will you discover next?